Yeah, hello everyone. In the last class, we already discussed how to minimize the expression, Boolean expression using Boolean laws and properties. Okay. Next, the method is K-map. It is the second unit. First chapter is K-map. So this is also the method to minimize the expression. Minimize the Boolean function using mapping method. So that mapping is a K-map. K-map means kern map. Kern map. Okay. So we have to minimize the given min terms or max terms. That means finally we will get the minimized expression. That expression is a Boolean expression. So we already discussed what is min term, what is max term. Standard SOP terms is called the min term. Standard POS terms is called the max terms. Okay. So now we are going to discuss K-map, kern map. So this is a method to minimize the Boolean functions by using the min terms or max terms. So we already know how to represent the min terms, how to represent the max terms. Okay. So this is the method to minimize the function using mapping. So that mapping is mapped with the terms, adjacent terms. Adjacent means again here 1 bit change term. It's a very important 1 bit change term. So we have to map the adjacent terms. The condition is only 1 bit change. So what is the meaning of 1 bit? Suppose if we are discussing 0 0, the next term is 0 1. So here in this 2-bit representation, how many bits are different? That means based on the positions. Here first position 0 0, that is same. 0 1, only 1 bit is changing. Okay, one position is changing. So this is called the 1 bit change. Okay, suppose next 1 0, 0 1 and 1 0. For these two cases, 0 is replaced by 1, 1 is replaced by 0. So this is not 1 bit change. So this is a 2 bit change. Okay, but in this K map we have to map adjacent terms. That adjacent term is nothing but only 1 bit change term. Suppose again 1 0 and 1 1. How many bits are changed? So the first position, that is MSB position, is same. LSB position is changed. Okay, only 1 bit. Okay, so this is the condition, that is a 1 bit change condition. So in this K map we have different types of K maps. So that means that we have to depends on the input variables. That variables is nothing but inputs, the number of inputs representation. So based on that number of inputs representation, then we can define the types of the K maps. So that we have 2 variable K map, 3 variable K map, 4 variable K map, 5 variable. So up to 5 variable in our syllabus, up to 5 variable. So after that, then we can use the another method. That method is a Quine-Mecklers-Key method or tabular method. Okay, so more than 5 variable, so we can use the tabular method or Quine-Mecklers-Key method. So now we'll discuss how to map the terms by using the 2 variable, 3 variable, 4 variable and 5 variable. That variables is represented as the number of inputs. Okay, now we'll discuss 2 variable K map. In 2 variable, the terms input terms are the 2 variables. How many possible combination? 2 to the power of 2, that is 4 combinations. Those combination, the range is 0 to 3. Okay, the range is 0 to 3. 2 variable, the number of possible combinations 2 to the power of 2, total possible combinations are 4, the range is 0 to 3. Here maximum number is 3, minimum number is 0. Okay, how many bits are represent for this 0 to 3 range? So that maximum, that number of bits are depends on the maximum number. So 3 binary number is 1 1. Okay, that we have to represent the number is, we have to represent these numbers using only 2 variables, that means 2 bits only. Okay, here the range is 0 to 3. So the possible combination 0 0, 0 1, 1 0 and 1 1. These are the possible combinations. So two variable, the function, let us consider f of x comma y, that is equal something, that given terms are min terms or max terms. So before going to that, how to place the positions of the given min terms or max terms. So here we have only two variables, that variables is, let us consider x and y. Okay, x and y. So for this x and y representation, here you can consider here x, here y, whatever may be x and y. Here the only single variable, the possible combination 0 and 1. Here also single variable, the possible combination is 0 and 1. Okay, here the box, first box that we have to represent row and column. This box is indicates 0 0, row indication, column indication. Next box 0 1, the row is 0, column is 1. Next box, the row is 1, column is 0. Okay, this box indicates row 1, column 1. Okay, so according to this binary numbers, this is the 0th position, this is the 1 position, this is the 2 position, this is the 3 position. Okay, these are the positions of the min terms or max terms. So according to that row and column representation, that we have to represent the min terms or max terms positions. Okay, so based on the row and column, then we can define the positions of the given terms. Okay, so according to that we have we can map the adjacent terms. Okay, now we'll see one example in two variables. So here it is, the function f of x comma y, that is equal to, the range is up to 0 to 3 only. So that means summation of small m, that means SOP, sum of products, summation of small m, that means min terms. So just I am defining 0 comma 2 comma 3, 0 comma 2 comma 3. Okay, then how to map the terms. Okay, here we know the places. Here let us consider x, here the y. So 0 1 0 1. Here the terms, given term is 0 position, next 2 position, next 3 positions according to this. Okay, 0 position, 2 position and 3 position. So now we have to map the terms, given terms. How? So here the k map is mapping with only adjacent term, that adjacent is nothing but only one bit change term. Okay, so according this binary number 0 0 0 1, how many bits are changed? Only 1 bits. That means 0 is adjacent to 1. Okay, 0 1 0 0, how many bits are changed? Again 1 is adjacent to 0. So both are mutual adjacent to each other. Next 0 2 0 0 1 0, how many bits? That LSB position is same, MSB position is variable, only 1 bit change. So that 0 is adjacent to 2, 2 is adjacent to 0. Okay, next 0 1 1 1, only the MSB position, LSB position is same, MSB position is variable. So that means here also only 1 bit change term. That means 1 is adjacent to 3, 3 is adjacent to 1. Okay, next 2 1, here 1 0 0 1. So that means 1 and 2 is not adjacent to each other, because here 1 is 0 1, 2 is 1 0. The two positions are changed. That means we can't map the 1 and 2. Like same 0 0 1 1, 0 and 3. So this not adjacent. So 0 1 is adjacent, 1 0 is adjacent, 0 2 2 0, 2 3 1 3 adjacent to each other. Now according to that, these two are adjacent to each other. These two are adjacent to each other. So the given function is min terms. Min terms means SOP function. So the SOP function, sum of products. So what are the specifications of sum of products? So 0 is represented as with complement, 1 is represented as without complement. The input variable representation, 0 is represented as with complement x bar, 1 is represented as without complement. So according to that, here 0 position is adjacent to 2. So these two are mapping to each other. Okay, then we can define, so how many rows and how many columns it indicates. Okay, so 2 rows, it indicates 2 rows, single column, two rows the terms are the different, one is 0, one is 1. Okay, directly it is the column representation, it indicates all terms. So that means directly it is a column representation, the column indicates 0, so that 0 is position of y position. So then we can, according to this term is y bar. How? Y bar. Okay, so it is a directly column representation, that column indicates 0 position, the 0 indicates y. Okay, SOP, according to specification of SOP, 0 is represented as with complement. Okay, like say again this term 3 is adjacent to 2, again 3 is adjacent to 1 also, but here 1 is not given. Okay, we have to map with only given min terms. Okay, again the 3 is adjacent to 2, so again we can map number of times based on the adjacent. Okay, so again 3 is adjacent to 2, here this indicates single row, two different columns, single row, two different columns. So directly we can consider as directly row representation, that row indicates 1, the row indicates x. Okay, x in SOP without complement, that is x, that is a row representation, this is a column representation. So directly we can write it, that expression f of x comma y is equal, the terms according to this function x plus y bar, x plus y bar. Why it is used summation? Because the given function is SOP function, sum of products, summation, all the terms with sum. Okay, so this is a two variable min terms representation. Min terms are max terms, position representation and mapping representation. Okay, next three variables, how to represent the three variables function. Three variables. So what is the range of three variables? How many terms that we have to represent? Three variables. Three variables mean three inputs. That means the range 2 to the power of 3 possible combinations. 2 to the power of 3 possible combinations. So that we can write it 8 possible combination. The range is 0 to 7. The range is 0 to 7. How to represent the 0 to 7 min terms in K-map? So that we'll discuss. So in that, how many bits are required to represent the 0 to 7 numbers? How many bits? Here the minimum number is 0, maximum number is 7. Minimum number is 0, maximum number is 7. How to represent? So three variables that we have to represent, 3-bit representation. So 0 to 7, 7 maximum number, that we can write it, the binary number is 111. So maximum bits is 3 bits. Okay, maximum number is 7, 7 requires 3 bits. So that is a 3 variable representation. So 0 to 7, so how they are placed in K-map, that we'll discuss. 3 variables that we have function representation x comma y comma z is equal something, that function that we can consider either SOP or POS. Okay, SOP or POS. So here 3 variables representation. Here this time consider this is the x, this is the yz, x, y, z. Here how many variable? Only single variable, that we can write it 0 and 1, 0 and 1. Now yz, yz 2 variables. How to represent 2 variables? So here it is 2 variable possible combinations are the 0 0, 0 1, 1 0 and 1 1. The possible combinations in 2 bits. Okay. So here it is. What is the condition for K-map? It is mapping with only 1 bit change. Okay, 0 1. That means how many bits are changed? 0 0 0 1. Only 1 bit change. Next 0 1 1 0. How many bits are changed? First position change, second position change. So these two are not adjacent to each other. Next 1 0 1 1. So these two are adjacent to each other. Next 0 0. So these two are not adjacent. This one is not adjacent. So for the condition 1 bit change condition, regarding that I am interchanging these two positions. Now we will see. So 0 0, 0 1. So interchanging these two positions. Next 1 1, 1 0. Now we have to check 0 0 0 1. How many bits are changed? Only one bit. Okay, like same 0 1 1 1. How many bits are changed? This position is fixed, this position is variable, only one bit. Okay, next 1 1 1 0. How many bits are changed? This position is fixed, this position is variable. Okay, only one bit change. Next, from this to this 0 0 1 0. How many bits are changed? Only one bit. So we have to, if we are interchanging these two positions, then each and every number is adjacent to each and every number is adjacent to each other. So for this condition only I am writing here 0 0 0 1 1 1 1 0, the possible combinations. Okay, so according to this binary numbers, just I am defining the positions, binary number positions. So here it is 0, the row representation is 0, column representation is 0 0. Okay, like same, row is 0, column is 0 1, again row is 0, column is 1 1, again 0 1 0. Here also same, here row is 1, column is 0 0. Next row is 1 0 1 column. Next triple 1, row 1, column 1 1. Next row is 1, column is 1 0. Column is 1 0. So according to this, what is the numbers? Decimal numbers for the binaries. 0 0 0. So this is a 0 position. 0 0 1 1 position. 0 1 1, that is a 3. 0 1 0 2. 1 0 0 4. 1 0 1 5. Triple 1 7. 1 1 0 6. Okay. Here the two positions are interchanged, then that binary, the numbers, the decimal numbers are also interchanged. These two rows and these two columns. Okay, so these are the positions in three variable K-map. Okay, everyone understand? These two interchanging. So that's why you can represent 0 1 3 2 4 5 7 6. 4 5 7 6. So now we'll see how to map the terms. So just I am writing here f of the function x comma y comma z is equal summation m of, that we can consider any number, that is 1 comma 3 comma 4 comma 5. 1 comma 3 comma 4 comma 5. Is it okay? 5 and 7, that we can consider 7 also. Okay, see. So here it is, positions of the given terms x, y, z, input variables. Here 0 0 0 1, interchanging them 1 1 1 0, here 0 1. So what are the positions? Given positions 1, next 3, next 4, next this is the 5, this is the 7. Okay, now according to the condition, adjacent means one bit change. These are all adjacent to each other. So here it is, here the first, this one. So 1 is adjacent to 3, 1 is adjacent to 5. Why? Here 0 0 1 1 0 1, these two positions are fixed, only one bit. So that is the MSB position is variable, remaining two positions are fixed. This 1 is adjacent to 5, only one bit change. So 1 is adjacent to 5, 1 is adjacent to 3. Okay, 5 is adjacent to 7, 7 is adjacent to 5. So that means these two are adjacent to each other. Again these two are adjacent to each other. Again 1 and 3 are adjacent to each other, and 3 and 7 is also adjacent to each other. That means these four are adjacent to each other. Okay, these four are adjacent to each other. That's why we can write it, this is a square map representation. It indicates 2 rows 2 columns. It indicates 2 rows and 2 columns. 2 rows, what are the possible combinations? 0 and 1 is a variables, 0 and 1. So we can't represent the row, so directly we can represent the column. So that is a 0 and 1. So from these two columns, so what is a common term? That means common positions from these two column representation. Here 0 1 and 1 1. So according to this, the position LSB position is fixed, MSB position is variable. Okay, thus that we have to represent only fixed position. So that fixed position is Z. Okay, that second position. So that second position is Z. So according to the SOP specification, 1 is represented as a without complement. Directly we can write it Z. Understand? Now, so these are remaining term. So this one is adjacent, that means 4 is adjacent to 0, 4 is adjacent to 5, 4 is adjacent to 6. So here 0, 6 are not given. So now we have to map 4 is adjacent to 5. Again we have to map the 5. Okay, 4 is adjacent to 5. So for this mapping, how many rows are represented, how many columns are represented? Only single row, 2 different columns. Single row representation, that is x, 2 different columns. So single row, that is only representation is x. In the 2 columns, common term is, that is 0, that is the first position. 2 columns for these two, first position is common, remaining position is variable. So that first position is y. Okay, first position is y. So according to the SOP specification, 0 is represented as a with complement x bar. Okay, so here, so summation m, that we can write it f of x comma y comma z is equal to x y bar plus z. So this is the minimized expression for the given min terms. Minimized expression for the given min terms. Everyone clear? Next, one more example for the 3 variable K map. So the function f of x comma y comma z is equal to summation m of 0 comma 2 comma 5 comma 6, 5 comma 6. Okay, so we'll see here again, like same K map representation, x y z input variables. Okay, here 0 0 0 1 1 1 1 0 0 1. So first we have to place the given min terms. So 0 position, next 2 5 6. Okay, 5 and 6, 0 2 5 6. Now for these two are adjacent to each other, that we know, these two are adjacent to each other. Then what is output for these two? It indicates how many rows and how many columns. 2 rows, 2 rows, single column, 2 rows, single column. So that rows are different, 0 and 1. Okay, we can't represent the row directly. This is the column representation. That column is 1 0. 1 0 is represented as y and z position. So 1, that is the first position is 1 is y, second position z is z bar. Okay, y z bar. Next, so this 0 position is adjacent to 1 4 and 2. 1 4 2. 1 4 is not given. So that 0 is adjacent to, the term is 2. 0 is adjacent to 2. So for these two, so what is output for these two? How many rows? Single row, single row. That single row representation is 0. That 0 is the x position, that means x bar. In these 2 columns, common term is a 0. 2 columns common term is 0. So that is a 0 is the second position. That second position is represented as z. So in 0 is z bar. Okay, is there any left term? Yeah, here it is one more term. So this is term is 5 is adjacent to 4, 5 is adjacent to 1, 5 is adjacent to 7. The terms are not given. The terms are not given. So we can write it directly. We can write it directly. That is based on the row, column, rows and columns. Row representation is x, column representation is y bar z. Understand? So 5, there is no adjacent terms. We can write it directly based on the row representation and column representation. That is a single row, 1 column is 0 1. So x y bar z. Thus f of x comma y comma z is equal x bar z bar plus x y bar z plus y z bar. Okay, so this is the minimized expression. Minimized expression for the given 3 variables. Clear? So here in that output there is no common terms. Okay, so that's why it's called the minimized expression. Okay, next we'll discuss. So these are the only min terms, that means SOP terms. So what about POs? How to represent the POS expression? So that we'll see